Hello everyone, my name is Misty and today we're going to be coding Perlin Noise from scratch. So as you can tell from the title, this is the simplest code you'll ever see and it can create infinite worlds. I believe it's what Minecraft uses, or they use a version of it to generate worlds based on seeds. So let's get to coding. So we've just got an empty directory called Perlin Noise. We can open NeoVim. And somebody asked for my editor config. Just look up LazyVim installation. Mine's basically stock. It's very nice. Gives you a lot of keybinds. Gives you a full IDE, really. Gives you LSPs. Gives you everything. Very nice. So let's create this. Let's create a perlin.c and a main.c and a perlin.h. Okay. First of all, let's write perlin.h here. And then we can just do an include guard. Or I'm not doing that, I'm doing a pragma once, but it's because I'm on a newer version of C. Let's create a function. And then, yeah, I think that's all we need. Then in perlin.c, we can include perlin.h. Then, I can't lie, I am not writing all of this. So I'm just going to copy this. This is just a massive array of numbers. Let me explain it. So the guy that made Perlin Noise is called Ken Perlin. And this is his original permutation table. 256 shuffled values from 0 to 255. This gives us a repeatable pseudo-random way to pick gradients. And we duplicate it twice. So as you can see, we duplicate it. So this is just the same array again twice. So we don't have to worry about wrapping, and we can just index up to 511 without modulo. This will make more sense in a minute when I start writing the main.c file. So let's write this. This is the hard bits already done pretty much. I haven't actually wrote the actual Perlin function. I'm really stupid. Let me write this. So this is the fade function. This is the smoothing curve that Perlin came up with. So we'll have a double T and we'll just return T times T times T times T times T times T times a lot of T times 6.0 minus 15.0. And the reason we put in 0.0 is because it's a double and we don't want to reduce it down to an integer. So that's that. Then we want the standard linear interpolation between A and B by a factor of T. So this is just lerping. Static double lerp double T double A and double B. Return A plus T times by B minus A. It's just standard lerping. Then we're gonna do the gradient function. So this picks one of 4 directions based on a hash. And each corner of the grid cell gets a pseudo-random gradient direction. And we compute the dot product of that gradient with the distance. And with the distance vector from the corner to our point. This is the core of Perlin Noise. So static double gradient in hash double x double y. And we can do in h equals hash 3. Only need 4 gradients for 2D. Yeah. If we're doing 3D, a bit more complicated, but we're only doing a 2D representation today. So, yep. Then we'll just do double V equals height. It's less than 2. Then we'll do Y. Else we'll do X. And then we'll just return H and 1, or then we'll use minus U, else U. Then we'll add H and 2. Then we'll use minus V, else we'll just use V. Yep, I think that's good. And then this is the main Perlin noise function. So we'll just do double Perlin. It's got to match the header file. Let me just double Perlin. There we go. Hello. Yeah, thanks. Right. Double X, double Y. And then int xi equals cast to an int floor of x and 255. Then int yi equals cast to an int floor y and 255. Call to undeclared library function. Do I need to include math, I think? Yep, cool. Then we'll do double. So now we're going to get the position in the cell. So double xf equals x minus floor x. And then we're going to do the same with y. Equals y minus floor y. And then we're going to get the fade curve. So this smooths the interpolation, so there's not any harsh transitions. So say you got a gradient between 1 and 0. You're going to want to fade it through, so it goes like 1, 0.9, 0.8, all the way down to 0. Otherwise, it will just go from, say 1 is black, 0 is white. It's just going to go from black to white. It'll look really harsh unless you fade it down. So this is what we're going to do now. We're going to do double U equals fade xf. That's the function we just made. Double V equals fade yf. And then we're going to do int. This is, we'll hash the 4 corners of the grid cell to get gradient indices. The permutation table gives us pseudo-random but deterministic values. So we'll do int AA equals perm xi plus yi. And then we'll do int AB equals perm xi plus yi plus 1. And then we got to do int BA equals perm xi plus 1 plus yi, I think. Int BB equals perm xi plus 1 plus yi plus 1. And then double x1 equals lerp. So this is a function we just made. We'll do u grad gradient AA xf yf. That's it. Then we're going to do gradient of BA xf minus 1.0 yf. And then double x2 equals lerp u. And we'll do a gradient between AB xf yf minus 1.0. And then we're going to do another gradient. You guessed it, BB XF minus 1.0 and YF minus 1.0. And then we'll just return lerp v x1 x2. That's the main Perlin noise done. That's pretty simple. Now we need to display it. So let's do include Raylib. I can't spell include. Include Raylib and include Perlin.h. And then define width. This is the width of the window. So define height. We're going to do 800 by 600. Define scale 0.01. So this controls the zoom. So imagine, kind of hard to explain. So imagine there's a window. The window that we're opening, that's like a view of the Perlin noise. The zoom, if we put that at 0.01, we're going to have very zoomed in. The smaller is more zoomed in. So we're going to be looking very close to the Perlin noise. But then if we make the number bigger, we'll get more detail and we'll be more zoomed out. That probably wasn't the best explanation, but yeah. So we're going to do color, terrain, color. I'm English, so I'm going to say color, double noise, double N equals noise plus 1.0 divided by 2.0. So what we're doing now is we're just defining what different values look like on a map. So we're going to visualize it like a Minecraft world, basically. So like I think the lowest is going to be water, and the highest is going to be snow. We're going to do that. We're going to do the definitions now. So we'll do if n is less than 0.35, and we're going to return color. We need to cast to color. Dot r equals 30, 60. I've got these written down. I'm not just thinking of RGB values off the top of my head. But yeah, we can just no point copying that. We just need to do a couple if statements. I'm actually just gonna copy these because I am not writing these myself. That is effort. Hold on. So yeah, I've just wrote these before because obviously I don't know RGB off the top of my head. I'm not a computer, bro. But yeah, that's the train color function. Then in main void, we don't really want any arguments for this. So we're going to do init window width height Perlin noise terrain. Then we're going to do set target FPS. We'll just go with 60. Doesn't really matter. It's going to be a still image. So gen image color width height color black. I can't spell black. Okay, and then for int y equals 0, y is less than height. So now we're just determining what color each pixel should be. So we're just going to iterate over each pixel. X++, and we're going to do scale the coordinates. So this is how we zoom in. So if we do double nx equals x times scale, and double ny equals y times scale. And then we're going to do double noise equals 1.0. No, sorry, 0.0. Then we're going to do noise plus equals 1.30 times Perlin nx. So this is basically just maths. I'll be real. But ny times 1. This is the base shape. Now we're going to do some details. So we'll do medium details. So 0.5. 500 times Perlin nx times 2 and ny times 2. And then let me just yank that and then just paste that twice. So 0.5 will change to 0.250, and then we'll do 0.125, and then we'll do 4 and 4 and 8 and 8. 4 and 4 and 8 and 8. That's not an 8 and 8. Think that's good? Yeah. Then we're going to normalize back since the octaves can push past -1 and 1. So we're just going to do that noise 1.0 plus 0.5 plus 0.25 plus 0.125. Then we're going to do image, draw, pixel, destination of the image, X, Y, terrain, color, noise. I think that's all good. Okay, cool. Now we're going to do texture 2D. Texture equals load texture from image. Image. I'm going to do unload image. Image. So the CPU image is no longer needed because we're loading it with the GPU now. So we're going to do while not window should close. Begin drawing. And then we're going to draw texture 0, 0, white. End drawing. And then after this, we're going to do, so after this will trigger when the window is closed. So we're going to unload the texture and we're going to close the window. Window. Am I stupid? Window. Cool. And then we're just going to return 0 or return exit success. I need to include standard lib.h. And then we can do, what's the command? Oh god, gcc tac o main.c perlin.c tac l raylib. In main, what am I doing? Oh, I forgot semicolon. Undefined reference to symbol floor. Because I need to tac L math. Tac LM. Okay, it compiles. /main. There we go. So this is basic Perlin noise. As you can see, this is the colors we was doing. So we have deep water being dark blue, shallow water being lighter blue. Then we have sand, grass, forest, and then I think that's a mountain. Do we have any snow? We should have some snow. Maybe not in this one. Let's change some values. Let's change the scale. So I think it was bigger means more detail. Let's change scale to like 5. Doesn't look like it's changed much. Maybe I'm wrong. Let's change width and I need to recompile. Oh god, I'm stupid. And now we're so zoomed out, we're just all green. Let's change this to like 0.5. Hold on, I need to recompile. as you can see, the detail is there. I mean, we're so zoomed out, you can't see anything. But let's change this to 0.2 maybe. Okay, we're seeing differences. What about 0.05? Recompile. There we go, that looks better. So this is basically what Minecraft uses, or any other procedurally generated game, to create worlds. It's very useful. Has a lot of uses, and it's yeah, it's very interesting, really. We just put loads of numbers into a function. We got this. It's pretty cool. So yeah, thank you for watching, guys. If you like this video, make sure to like and subscribe, and leave a comment. I'm down to answer any questions. And I'll see you in the next one. Cheers, man.